In this section, we are going to be analyzing data for a particular organization that sells motorcycle parts. So we are going to be performing some exploratory data analysis to answer some questions regarding to the data. So as you can see our data here, we have the dates in which an item was sold. We have the warehouse where the item was sold. We also have the client type, as you can see, whether the client is on retail or wholesale. This is a factor, this is a categorical variable. You can see we have two variables, retail and wholesale. So we also have the product line where this product belongs. We have the quantity of item that was bought. We have the unit price in which the item was sold. Then we have the total amount that was spent on that particular item. We also have the credit card. So if you can see now, this data consists of each sales of a particular product. So, and those products belongs to a product line, and this client type shows us which type of clients bought that particular item. Was it a retail or a wholesale? Was it sold on retail or sold on wholesale? Also the particular warehouse where it comes from. So I'm going to be answering various questions based on this data set. So the questions we'll be answering is just to show some of the principles that are used for exploratory data analysis in R, and also we're going to be using the Tidyverse R package. So in this video, I'm going to be showing the packages I'm going to be using for this section. We are going to be using the Tidyverse packages. The Tidyverse package is actually an umbrella package that consists of other smaller packages. So the Tidyverse packages are designed mainly for data science in R. We all know that R is a statistical language designed by statisticians for statisticians. So this Tidyverse packages it eases the process of data science in R. It allows data scientists to be able to perform various data science operations using R. So the Tidyverse packages, if you don't have the Tidyverse packages, if you want, this is actually an R Markdown file. For those of you that are not familiar with an R Markdown, it is a file format in R similar to Jupyter Notebook. So when you run a code chunk, the display of your code chunk, either visualization or your data shows below your code chunk. If you want to create an R Markdown file, you go to this drop down arrow, you click on R Markdown, and an R Markdown file will be created for you. If you don't have the Tidyverse packages, you can type in install those packages and Tidyverse. So this is going to load all the packages in the Tidyverse for you. After loading the Tidyverse packages, you are going to see packages such as ggplot2, core, table, dplyr, tidyr, stringr, readr, and forcats. So the ggplot2 is R's data visualization library. For using that, the Tidyverse visualization library. We have core, which is used for functional programming. We have table, which is actually a way of storing data frames in R. We also have the dplyr for data manipulation. We have tidyr for tidying the data. We have stringr for string manipulation. We have readr for loading data. And we have forecast. Readr actually loads various types of data. Then we have forecast for handling categorical variables. So these are the packages you are going to be getting when you install the Tidyverse. If you want to load the Tidyverse package, use library Tidyverse. You type in library Tidyverse, and this is going to load all those packages for you. Once you type Control Enter, this is going to load all those packages for you. So those packages can actually be loaded one by one, but it's best when you want to perform data analysis to load all the Tidyverse packages. The next thing is to load in our data. So we are going to load in our sales data, which I've actually described in the first video of this section. So we are going to name the data sales. Once we name the data sales, or let's say sales data. So once we name the data sales data, we're now going to carry the file path. So this is the data here. I'm going to import data set. I just need the file path. So this is the file path. Or you can actually copy all of the code you are seeing here and paste it. And you can see, once you load it, so you can see our data have 1,000 rows and 8 columns. We have 5 character variables: date, warehouse, client type, and product line. We have 3 double variables, or we can say these are numeric variables, which is quantity, unit price, and total. So in summary, we are actually dealing with 8 variables. So let us have a view of our data. View sales data. So you can see this is the sales data. This is the date column, which is actually the date and item. was purchased. You have the warehouse, the client type, the product line, the quantity, the unit price. We have the total and the payment method. So the payment method is actually categorical 3. We have credit card, cash, and transfer. These are the method of payment that was made. So let us just see a basic summary of our data. We actually want to know, that's especially for the numerical variables, which variables are actually, what's the mean of, for example, the quantity, what's the mean of the unit price, what's the mean of the total, the maximum variable. So stuffs like that are what we actually want to see now. So there is a package that I'm going to load now. Though I will not load the package, I'm just going to use the function directly. Because I'm going to be using the function from this package once, that is why I'm going to be loading the function directly with the package. So this package provides an alternative to the R summary functions. So I'm very sure you are familiar with R summary, which actually summarizes a data. So this scheme R actually works similar to that, but difference is that this actually brings it out for you in a much more nicer format. So I'm going to say scheme R, scheme, then our scheme sales, data. So as you can see now, this is the output of the scheme R. So in one side, we have the whole data summary. So number of rows 1000, we already know that. Number of columns, we have 8, and we have column type frequency. So, and in this other window, you can see the character variables in this other window. We have the date, the warehouse, the client type, and products line. So we have no missing values under the character variables. You can see complete rate, you can see other values also, number of unique white space, if there is white space in any of the variables, which we don't have. Then let's go to the interesting part, which is actually the numerical variables, the quantity, the unit price, and total. We are good to go. We have no missing values. You can see the mean of both of the variables that are numeric. We can also see the standard deviation. So this is the 0th quartile, or can say 0th percentile. This is the 100th percentile, which is actually the maximum value, and the 0th percentile is the least value or the minimum value. We also have our histogram, which shows us the distribution of the data. So that is all for our data summary. From this little thing, you can just know something about our data. By observing it, you can actually see that the mean of the quantity is actually 9. So let me make the window larger. So we can see the mean. We have a mean quantity of 9.4. We have a average unit price of 30.3, and we have the total amount, the average total amount of 289.11. So this is just actually give us a glimpse of our data and how our data looks like. The first question we are going to be answering now, we want to know the total amount that was made under each payment method. We want to know the payment method that clients actually like or clients actually use the most. So we want to know the total amount that was made under each payment method. So this is where our dplyr package will actually come, because this is a data manipulation I actually want to be doing. So now we're going to we want to group our sales data. We're going to group our sales data. We group our sales data using the group by function. We group it by payments. This is going to group the data by the payments, which we can actually now make a summary. We're going to now summarize by adding the values in the total column. As you can see, we add the values, summarize. So we're now going to call the name of this new column, because this will actually generate a new column for us. We're now going to call it total, which is equal to sum of the total column. So this is going to sum all the total payment that was made under each payment type. When you run this, you can see we have the various total that was made under each payment type. The least we can see from here is the cash with $19,000 plus dollars, and the highest is transfer. So most clients actually pay through transfer than credit card, and most clients actually pay through credit card than cash. This is understandable because it is much easier to pay through transfer and through credit card. But sometimes in data analysis, it's actually good to visualize your data. So we actually want to represent this in a much more visualized format. But first of all, we want to represent in a data visualization. We have to convert it to percentage. This allows us to see the differences clearly in each payment type. So we're going to use the mutate function to create a new column, which is actually going to be the percentage. So we call this column the percentage, which is equals to be, and percentage we know is going to be the value of each payment method divided by the sum total multiplied by 100, which is going to be total, sum total, multiplying by 100. So when you run this, you can see now we have our total, we have the payments made under each payment type expressed in percentages. This we can now visualize. So let's visualize this and see. I'm going to be using the ggplot2 library. So inside the statistics, we are now going to give our coordinates. First of all, we have x is equals to payments, and we have y is equals to percentage, and we're now going to use geom column. So the ggplot2 actually use plus geom column to express it in a bar plot, a column plot. So this is our graph, as you can see, but our graph is not looking nice, it's not colorful, and we want to give it some colors. But we can already see and understand from this graph that most of the payments that was made through transfer, most of the total payments was made through transfer, then credit card followed by cash. So let us give it a color. Let's group the coloring by the payment type. So we can actually do this by going back to our code and giving fields equals to payments. By the time you run this, now we can see we have something colorful. So we already have our data visualized now. So this is much more better than presenting it in a table. But to view it now, you can see it is much more better than the previous graph we created. We're going to say xlab payments method and we say ylab percentage of total sales. So much more better. So you can see percentage of total sales and payments methods. So it is much more, it's better explanatory like this. So in summary, the transfer payment type, most of the clients actually prefer or use the transfer payment type than the credit card method and cash payment type. The next question we're going to be answering is going to be the average unit price of each product. So we want to know what is the average unit price of each product. You can see that we have a column that gives the unit price of each product. So we want to know that under each product line, what is the average unit price of products belonging to the product line. So we create our code chunk. So just like we did in previous lecture, we're going to use the sales data. And this time around, because we're interested in the product line, we're going to be grouping by the product line. We're going to say group by. I'm going to group by product line. Once we group by the product line, then we're now going to summarize because we want to know the average unit price of products belonging in the product line. Then we'll now say average. Let's call it like this, average unit price. So let's create a new column like this. It's equals to mean of the unit price. So first of all, let us view this. So you can see that under the braking system, the average unit price is 17.7 and so forth. You can see for each data, but we want it to be much more arranged. So let's do it in a descending order so that the highest unit price is going to show at the top and the lowest is going to show at the bottom. So this is where the arrange function actually comes. So we now use arrange average unit price. So it's much more better. We can see that the highest unit price belongs to the engine category, then the lowest belongs to the braking system. So we're also going to visualize this and present it in a column plot. So we use the ggplot library. And we give the values of the coordinates. So the X is the product line. And and they have Y. The Y is at the average unit price. The column we created, average unit price. I'm going to say geom column. So let's actually give the field. The field is also going to be product line. So we're now going to use geom column. So this is our graph as you are viewing. But if you notice, you can see most of the names of the product line are overlapping each other, like miscellaneous suspension and traction. We also have braking system and electric system. So we are going to flip our data so to make the x-axis showing by the vertical line, and we have the y-axis showing on the horizontal line. So we are going to flip this data to make it much more presentable. And also another thing is that we want it to go in ascending order. We want this graph to either go in ascending order, in descending order. It's going to look much more neat and much more orderly. So we go back to our graph and make some few changes. So we are going to remove this product line and use reorder. Reorder is a function that belongs to the forecast library. So what reorder is going to do is going to reorder the graph based on products, from the lowest product to the highest product, the highest product unit price. So you can see it looks much more better. So we are from braking system to the highest. What is now left next is for us to flip the graph. Flipping the graph is not a problem. You just add the coord flip function and your graph will be flipped. So you can see now that our graph looks flipped. It's much better than before. So we also have to change the labels of the x-axis and change that also of the y-axis. So you go to here as usual. X lab is going to be product line, and we have Y lab that is now going to give us average unit price. When you run this, so it's much more better. So we can see that at our x-axis we have already changed the label, and also at our y-axis we have changed the label. The next question we are going to be answering now, we want to get the total purchase value by product line. So what is the total purchase value under each product line? So we are going to use the sales data. So what are we going to group it by? You guessed right, we are going to group it by the product line. So once we group by the product line, we're now going to summarize, create a new column, which is actually going to get us the sum total of each product for under each product line. If you go back to our table, so we're going to get us the sum total of each product under each product line. So to summarize, total sales, sum total. So you can see that the sum total of sales that was made under each product line as we are viewing. We also want to compare these to percentages to see the differences between various product lines. So we're going to create a new column by using the mutate function. We'll name it percentage. What we name it percentage, we're now going to say equals to total sales. So this is the column we created, which is in summarize, divided by sum of the total sales, then we multiply it by 100. So you can see it's much more better. So what remains, it is not ordered, we need to arrange it. We're going to use the arrange function. So we're going to arrange it in descending order of the percentages. We're going to say percentage. So it's much more better. We can now see that the percentage of sales made was from suspension and traction. Of total sales made from suspension and traction was 25.25%. We also have that of frame and body, 23.9%. Then the lowest is what? Miscellaneous items. So I'm going to leave it to you as an exercise for you to visualize this table and see what you have. So hope you are able to visualize it. If you can't visualize it, then I'm going to do it in this video. So we are going to use the ggplot2 package. ggplot So we're going to give our coordinate s equals to reorder, because we want to reorder it by the percentage that was the percentage. We are going to reorder it by percentage from the lowest to highest to be displayed on the graph. Then our y is equals to percentage. Then in y we now have fill is equals to product line. Next, we are going to use coord flip to flip it, because we have a lot of variables, as you can see, a lot of. So we have suspension, traction, frame and body, electrical system, braking system, engine, and miscellaneous. So we're going to use coord flip, then X lab, product line. So it's to give the name of our X axis, and Y lab, percentage of sales. So when you run this, you're supposed to have your plots, though we might have made an error. Okay, we haven't given the type of plot. We're using geo column. So you can now see our data is looking very beautiful. So that's all for this section. We want to use exploratory data analysis that it never finishes. So with exploratory data analysis, you can use it to find out a lot of information about your data.